Hello, fellow chemists. Jolly here. This discussion is going to be on those variable charge ions and how we're possibly going to predict or figure out what their true charge is. Now, the variable charge ions, remember that's a jolly term, variable charge, but these are the ones that you can't get from the periodic table. You have to know their environment. You can't get them directly off the periodic table. Now, if you go into your electron configurations, I have taught you how to predict the most possible ionic charge, but you can't get it right off of that periodic table. And so I need to know about its partner. I need to know something about its partner. And so I'm going to give you a couple of variations, and then we're going to work backwards. Now, what are those variables, though? We have the transition metals. We have the inner transition metals. And we have the representative metals. If you are not horribly comfortable with the periodic table and the terminology, I suggest you go back and watch my video on let's explore the periodic table and all the terms that we use and the reason for them. All right, so we've got our transition metals, our inner transition metals, and the representative metals. And let me just draw a very terrible periodic table. All right. The transition metals are right here. The inner transition metals are the actinides and lanthanides. And then the representative metals, remember, are along the, or not along, but under the staircase. They're under the staircase, and they do not include the metalloids. So they're under the staircase, or to the left of the staircase, and they do not include the metalloids. All right, what about these two right here? Remember, in a past video, these are your fixed, and right here, aluminum. Okay, those are your fixed charge. You can get them right off the periodic table. All right, so we need to talk about these variable charges. So I'm going to use a, I don't know, zinc chloride. Zinc chloride. Now, first of all, you have to recognize that it's an ionic compound, and zinc is a metal. Chloride is a nonmetal, so that's the basic definition. So yes, it's ionic. Can you tell me the charge of each piece? Well, zinc is a transition metal, so it is variable. So I am going to have to trust its partner. This one is a -1. So if I work backwards, I know this has to be neutral, and I know there are two chlorides. So zinc plus 2, and those chlorides are -1, has to be 0 because it has to be neutral. So zinc must be a +2. So what is the charge on the zinc in the zinc chloride? It is a +2. Now, for nomenclature purposes, this is called the stock system. If I can't get that charge off the periodic table, you have to tell it to me in the name. And so technically, the name would be zinc Roman numeral 2 chloride. Because if I just said zinc chloride, you would have absolutely no idea what the charge on the zinc would be. So that's called the stock system. And again, I highly suggest doing the nomenclature section if you're not comfortable with it, as long as it doesn't take too much of your time. But I do suggest you go back and you review that nomenclature section when you're doing these ions and these charges. All right, so let's try another one. Oh, oh, I don't know, let's say titanium nitrate. Okay, now what I just said, titanium nitrate, gives you absolutely no idea what its charge is. So let's use what we do know. Well, I know that that nitrate is a -1. So my titanium plus 4 -1s has to be neutral. So the charge on this titanium is a +4. And so my name should be titanium 4 nitrate. Right, what about the other way around? Can I figure out a variable anion? Nope, we only have variable cations. We only have variable cations. Right, let's try one more. How about lead and sulfur together? All right, you have to trust the environment. You have to trust what I gave you. And I know that sulfur, whoa, I did that really differently, sorry. I know that the sulfur is a -2 and there's one of them and it has to be neutral. So I know this lead is a +2. So this one would be called lead 2 sulfide. Where this one, can you picture it? Can you see what charge it is? This one would be called lead 4 sulfide. So for your variable charges, you have to trust the environment. You have to trust its partner, if you will, to work backwards. And then, of course, you have to put that in the name, or I don't know that you are talking about that specific ion because I can't get it off the periodic table. All right, that takes care of your variable charges. All right, until next time, Jolly out.